So now we're talking about circuits.
My brain hurts. We could even take like a 5-minute break.
That was 5 seconds. Actually, probably wasn't. You can probably tell. It was probably like 2. I don't really know.
Well, okay. Anyway, so capacitors.
Okay, she says it like that, and I'm really sorry that you're gonna have to listen to that the entire time. Because they're not tater tots, but apparently she finds them still delicious.
So, an important thing to note about capacitors.
You sound so smart when you talk about it, but I know you're really not. I just wanted to point that out.
That I sound smart when I talk about it?
Yeah.
Oh, that actually means a lot.
I meant to, like, degrade you by saying you're not, but I guess I didn't do a very good job of that.
I mean, I feel like I knew that I don't know anything, so, like, you can't really slander me on something I know, you know?
True.
So, that was just a compliment to me.
You're welcome.
You can't drag me down, I'm already too low.
I was gonna slap my knee, but I feel like that would be too much.
Anyway, so an important thing to note, dielectric constants. That's the thing. Sorry, I just saw something. So basically, when talking about a capacitor and resistors, so in a circuit,
We should talk about this thing. Okay. Wait, no,
go.
you keep going. Though.
Okay,
You had
so-
something good going.
a capacitor, it's like the opposite kind of a resistor. That's how my mind thinks about it. So
Yeah, that's a good way to think about it.
So if we have a battery, normally with a resistor,
Is it a battery?
yeah, that's the battery.
Batteries usually longer and shorter.
No, I thought that was a capacitor.
No, capacitors are parallel. You didn't know that this entire time, Reagan. Dear Lord. Literally any like that.
I straight have the opposite. I don't know what to tell you. Actually, mine are just all parallel.
Okay.
Anyway,
I'm glad you're learning this before the test.
so capacitors that are in series. This time, this is the one that sucks. This is the one where you have to take 1 over C plus 1 over C, and then you have to take the inverse of that. But this is normally for resistors. This is normally when resistors are in parallel. But when the capacitors are in parallel, that's when you just add them.
Yeah.
And
Like easy.
resistors are normally, you add them
When
when they're in series. And that's also on the yellow sheet if you know what that
It is?
Yeah.
Oh.
So,
Oh. Yeah, and so in this case, the capacitance would be C over 2 if they're the same, if they equal the same. And if those were resistors, then it would be 2 ohms. 2R. Okay.
what is the unit for capacitance, Victoria?
Yeah, I never knew that, even when we were taking the test. Because I remember not knowing that specifically when we were taking
I
the
remember
test.
I looked it up. I saw it. Oh, it's a Farad. It's a Farad.
That's actually really good to know.
It's Michael Faraday. Anyway.
Oh. Okay, so if let's change this up a little bit. Keep that. Okay, let's say these are in parallel. And so we already discussed that. Gosh, I'm so bad at drawing things. Okay, so let's say that these are in parallel, and we already discussed that they would equal 2C. But something that is good to know about parallel is if they're in parallel, it's like Mr. Holloway lost $10, and he gave the $10 to me, and then I gave the $10 to Reagan, and then Reagan gave the $10 back to Mr. Holloway. Or maybe he doesn't. No?
It's
Oh, is that when he gives $5 to Connor?
one of them is if he gives $10 to Connor, and I think
Oh
gives
yeah, I
$5 to
lied.
Colin.
I was talking about series. So yeah, parallel is when Mr. Holloway gives $5 to Reagan and $5 to Victoria. and that's how much capacitance that we get, or something like that. I don't really know what the dollars represent in this, but charge. Oh yeah, charge. Yeah, you're right. And then, but if they're in series, it's Mr. Holloway giving me $5, and then I give Reagan $5.
Mm-hmm.
Yeah. I already went over that. So resistance.
Important equation to note. Important equation.
Is this still with?
Yeah. Keyed and CV. So.
Keyed.
That's what I call it. Keyed. Keyed is equal to K times EA over D. Let's see where I get the keyed from. Keyed.
Is it equal or times?
Times.
Equals. Times. So is keyed equal?
Got to find out.
Is K the constant?
Yeah.
Okay.
Right, I have that this equals C, but do you know what C means now? Oh, Q equals CV. Q equals CV. Capacitance, voltage.
Okay.
Q.
And we're gonna ace this test.
Does
Is Q still heat, or are we not in that unit anymore?
I was just gonna say that, but this is a potential difference across the capacitor.
Capacitors. Potatoes.
And this is just so. This is a kappa. This is just a constant. This is
Small k.
the vacuum permeability, which is also a constant.
The E, yeah.
So these both are constants.
Ke.
Mm-hmm. And A is the area of
the
plate in meters squared. And D is the separation of the plates, which is typically a smaller number.
Tiny.
I don't know if I'd go tiny, but I just would say very small.
So also, if we're moving on to resistance, can we move on to resistance?
Mm-hmm.
So if the thing is hotter...
Oh, wait, no. One more equation. U is equal... This is also on the equation sheet. 1/2.
I already went over that one.
Okay.
No, we probably didn't. I could have been wrong.
1/2 CV squared.
Oh yeah, we didn't go over that one. Sorry for...
The thing. Just think about it.
Mojo.
Think about it.
Let's just sit here and think about it for like a little bit. That was good thinking time. Okay. So when talking about resistance equals the resistivity. That word. Times the length of the wire divided by the cross-sectional area of the wire, which I hope that we don't have to do. But if the wire is bigger, then if the wire's bigger, then we know that the resistance is smaller, because it's just like you're going through a huge cave instead of a tiny cave. So if it's smaller, it's going through a tiny cave, and when it's bigger, it's going through a bigger cave, and so we know that this is a very important equation.
There's more resistance, like, if you're trying to crawl through a small cave.
Yeah.
Is that what you're
Yeah, because it's harder to get through a small cave.
Yeah.
And current, just like this I right here, current equals change of Q over change of T, which is a thing, and then measured in amps. But this thing, Reagan, you should talk about this.
Beer.
Don't veer from the road. Do veer in physics.
Beer. Volts, maybe.
Yeah.
Or potential difference. Not
Same.
really sure.
Different.
One of the two.
The same.
It's on the equation sheet.
You got this.
Current.
Resistance. Ohms. Oh, current is amps. Sorry.
Amps.
What did you say? Current.
Yeah. Beer.
B equals IR. Fact. Okay, so when we're talking about capacitors, when we're talking about resistors, time is irrelevant. When we're talking about capacitors, eventually the current will stop
Oh,
going
well,
through the
that's not
capacitor,
bad.
and so once the capacitor is fully charged, no current will want to flow through that
But
branch.
before it takes all of the charge.
Yeah, correct. And and so resistance, if you put a resistor in there, it makes it take longer for the capacitor to be fully charged. Yeah. Something fun. Oh, that's Ohm's law.
Ohm's law!
Ohm's law!
Do you want to go with junction rule?
Oh, okay.
That's the only thing I've left.
Junction rule is when all the current... Okay, no, start over. Junction rule. All the current entering an electrical junction must exit that junction.
Mm-hmm.
So... Yeah, go ahead.
No, you go.
Yeah, no, you need to go. I was gonna BS something.
So, basically, if you have a circuit, right?
Two, yeah.
I didn't know what they were, if they were resistors or capacitors.
Oh. Yeah, not capacitors.
So basically what it's saying is, like you said, that they have the same, whatever you said. And so we know that the first time around it's going to go like this.
No, I don't really know what you're doing. Okay, that's not the junction rule. The junction rule has to do with current. So if there's like two
I
currents...
swear to God, I wrote different paths though.
Okay, so if there's two amps of current, so if I equals 2
And like
amps,
inner loop
and this resistor has 0.5 amps, then we know that this resistor has to have 1.5 amps, because we know at the end on this area, if there was an ammeter here, it has to equal ammeters measure current. It would have to
voltmeters measure volts.
It would have to.
Voltage of the
It would have. Are you gonna keep going? It would have to equal 2. So if we have 1.5 coming through here, we have to have 0.5 coming through here, so we can equal 2 in the end. So if this is 2 amps. Yeah, so that's what the junction rule is. The junction rule is if there's a change, like right here we switch and some people go down and some people go across, that they have to meet up and equal the same.
That's about all I have for that.
There's some way that you can measure multiple loops, but I don't really... Oh, no, this is fun stuff that I should just read. If you pull plates apart, like capacitors, and then that means the work is being done on them, and then that energy drives current backwards through the battery. It's just a fun little fact. And charge will always stay the same if the battery is disconnected, and voltage will always stay the same if the battery is connected. So capacitor stays the same if it's disconnected, voltage stays the same if it is connected. Yeah.
Oh, yeah. I learned that in my physics review session, and then later in my physics other review session.
Oh, with yourself?
Oh, I did that one video of the flippin' physics.
What? Flippin' physics?
Flippin' physics!
And they still store charge because... Yeah, I can't read my handwriting.
Moving on.
Internal resistance! VAB equals terminal voltage, what you really get. VAE equals weird looking E minus IR. I don't really know what any of that means, so we're just going to keep going. Oh, things to know.
I think that's just like, so we've already talked about those.
We've already talked about it. We've already talked about that. We've already talked about that. I think we can move on now.
I think we're good. Magnus isn't Zach, so
Stay tuned!